And I just want to say, as I'm kind of going through this little presentation here, if there's something kind of a burning question in the moment, by all means, you can stop me and ask. But we will have a portion toward the end where we'll kind of do some dialogue, sharing, answering questions. So what you're looking at on this slide here, and the images on the bottom are taken directly from the project that I designed specifically for this presentation. Now, I'm not working with a robotics team, and I don't have any like ongoing robotics projects right now, but I thought about some of the people I've worked with in the past, and also Dave Kemsky, who has shared some images with me on some of the projects that he's worked on. But what I did was I made, if you look to the far right, you're looking at just a very simple kind of arm assembly that uses aluminum and 3D printed parts. And I'd like to just kind of walk through the process with you. And I do have the water jet in the room with me. So if you do have any questions pertaining to that you'd like to see something very specific, let me know. But what I've done is I've pre-recorded a video of the machine running. It's pretty, as far as like the process of the machine running, it's, I think you get the gist of it just by seeing one job, since it's functioning on like a 2D work plane. But again, the machine is in the room with me if you do want to see anything specific. So, all right, so some of the things I'm going to just go over real quickly here. When I thought about the workflow for producing custom robotics parts, in my case, I was really just making an arm that could be affixed to like a robot chassis. So let's say you wanted to design some sort of flexible arm that was attached or driven by a servo motor. That's kind of what I was going for here. Again, I had nothing specific in mind as far as an end goal. I just wanted to make a functional assembly that you guys could see in action. So when I went through this, I asked myself, what are the project goals? And again, that was just kind of to demo the digital fab workflow here. I did my design in Fusion 360. We'll talk a little bit about that. I'll open up my file and go over some of those points. And then we'll take a look at the ProtoMAX software workflow, share some videos from that. And at this point, most of us, I feel like 3D printing seems like it's kind of old news, but there's always new stuff going on. So I'll share a little bit about what I did for this project with 3D printing. And then finally, assembly and troubleshooting. And I always love to ask the question, how can it be designed or integrated differently? I love asking students that question, teachers that question, myself that question, stopping myself in the moment and saying like, all right, I just kind of like barreled forward with the knowledge that I have and made something. But if I were to restart from scratch, how would I do it differently? Or if I consulted somebody, how could I achieve my goal in a different way? All right. All right, I'm just going to swap over to my desktop. Okay. All right, so you folks should see my desktop now, and I have Fusion 360 up. Can everyone see this okay? Kristen, is that coming through?
Yep.
All right, excellent. Okay, so kind of nice and compartmentalized. I love using Fusion 360. It's been my tool of choice for years now. So what I did here was I kind of started really with, if I hide everything. I started with this here. This was my main focal point, was just to make like, a part of the arm. And, I did a simple mirroring to just make two parts of it. But this was pretty straightforward as far as the design goes. And when we're working with files for our specific waterjet cutter, the ProtoMAX, we're really just working with it as though it's like a laser cutter. We have a tool head that points straight down on the z-axis, and we run the tool path and jet water mixed with a garnet abrasive to blow through the material. And after I've done my design in my CAD software, the workflow from here to the water jet, I just want to show you this real quick because it's pretty neat. After I've made like my 3D design, I can, hold on. I create a new sketch, and my new sketch ends up being a profile. Let's see if I have the right one here. A profile sketch of, it's not what I designed the part from, it's just a sketch that I want to use to make the tool pathing. So I'll go ahead and save this sketch as a DXF file, which is the only option I actually have on Fusion 360. And I'm going to open up ProtoMAX Layout. And ProtoMAX Layout is kind of like it's really kind of your 2D CAD software for the water jet machine. And oh, looks like I'm actually missing some stuff here. Sorry, give me 1 second. Oh, I see. I think I exported the wrong sketch. Oh no, weird. Okay, sorry, bear with me here. I might just have to open up a different file, but.
Adam, while you're doing that, we have a question.
Sure.
Can you use, I lost it, VCarve Pro for the water jet?
You might be able to produce, oh, I know what I'm doing wrong, sorry. You might be able to produce your artwork in VCarve, but you wouldn't be producing the toolpath. So that's the short answer to that. You could like make artwork in VCarve and then export the SVG. Yeah, what I was missing here is I should be importing from other CAD. There we go. Okay, here we go. All right, so here's a preview of my 2D artwork. And this is I believe, 1 inch by 1 inch grid space here. And as long as my 2D, rendering is fairly accurate here, I can just go ahead and click on Auto Path over here. And what we see here is a rendering of 3 different paths here. We have a traversal path, so where the water jet's tool head moves without actually jetting anything. We have lead-ins right here, these kind of brown lines, and that's when it starts to ramp up and actually jet out the water in the abrasive. And then, of course, pink is what it's actually cutting. You have quality options down here for 1 through 5, 5 being the finest. And you have an etch option too, if you want to do an etching. I'll show you a little piece that I did with that. But at this point, it's, if your artwork is true and your paths look okay, you can even like use some simple tools like cleaning your artwork up here to just do a check. And it might go through, some checks of like what, here a duplicate entity was removed. And then I can go ahead and click post, which says pick a start point. And my start point's going to be this spot, this lead-in or traversals point right there. Oh, something. I'm missing something here. Sorry about that.
Adam, can you use a 2D vector drawing from Corel Draw in Inkscape Boxy instead?
You can. Yep, you can absolutely. Yeah, what you just saw when I went into file and import from other CAD, you could make your design in Inkscape, you could make your design in Corel, Illustrator, and import it directly into here. Yep. Okay, there we go. And what we see here is a rendering of the toolpath. And you'll notice that here, it actually renders it. What we're seeing in this kind of like pinkish space here is the kerf of what actually is getting cut. But when we send this to the software that's actually running the machine, it knows that we are sending this to be cut through the material. So what it does is it adjusts the offset of the tool head so it cuts on the outside of the line. So we're getting a true measurement based on whatever we did in our CAD here. Let's save that. And then we switch over to ProtoMAX Make, which is how we're running our job, actually, performing. It's what connects to the machine. And this is my post file here, the OMX file. And though I know I'm missing some things here, it seems like whenever I try to replicate this workflow, nothing ever works out 100% of the time. But you get the gist of it here. So at this point, I would go through and select some of my, what I'm actually machining. Today, I didn't actually machine this out of steel. I did aluminum. And I could enter my thickness, which will play a role in how fast the machine cuts. The tool offset, which is set to a default, but of course could be changed. And then I click OK, and I get my final toolpath. At this point, I'm just testing, the machine and running the cut. And I may as well just go ahead and show you the video here. All right, so what you're going to see here is not the toolpath that I just showed you, but this is something that I just cut today. It's just a little hex wrench, and I wanted to just do a video of this because it's a smaller job. Now, this video is kind of more the comedic video because it does an etching, and you'll see why shooting a video of an etching is not optimal. I'll just run it for like a few seconds here. Okay, so so the etching, because it's jetting the abrasive mix right onto the surface and not cutting through the material, it just sprays water everywhere. So I found out that wasn't going to be a great video for you folks, but it was still fun to shoot that and produce a part that I'll show you later. But what we see here is I removed the path for the etching, and this one just cuts directly through the material. You can see the negative cut here, and this one came out really nice. And the material, if you can hear me, can you hear me, Kristen, right now?
Yes. Yeah.
Okay. Okay. So the material that is being cut is steel versus it's probably like it's a 1.5 millimeter thick steel versus the almost 1/4 inch thick aluminum I used for the other part.
So Han said that he couldn't see.
Han says it's not. Is anybody else having an issue seeing the video?
Yeah, I had to hit play and then you were still talking. So if I'm literally somehow I'm hitting play on my end and it's running, but kind of bouncing around, which doesn't really make sense to me because I don't know how I'm like I can click on play and pause on my end.
Okay. All right, interesting.
I'm able to see it myself.
Yeah, me too.
Yeah. Okay. Well, I can try another tactic here. So bear with me. Okay. Jim, how about that? You can see it?
Yep.
Yep.
Now I can't see it. I hit play and it started playing, but then it disappeared.
If you go back to your screen, do you see it? Because now Adam's did a different way of playing it.
Yeah, you shouldn't be able to hit play because I'm actually playing a video on my desktop right now.
Yeah,
So,
now that option is gone for me. I can't. But before it was there, it's gone now. And now I am seeing the video that you're playing.
yeah.
Okay. So it sounds like we're good now.
Yeah. I bet that the issue it has to do with me full screening the video. It's a lot of back end technical stuff that somebody somewhere will check in with to figure out.
I'm not seeing any video. I'm just seeing the people, whoever's talking.
I see. Okay. All right. So, I mean, I can try this one more time just to see if we can see. Okay. So at this point, I'm sharing my desktop, and I have a video open on the desktop. Is there anyone not able to see that?
That's good.
Okay.
I can see it.
I'm good. I can see it. Excellent. Thanks for bearing with me, everybody. So, so you're seeing the jetting actually stops in between different tool paths. So if a tool path ends, it will do, or there's a big traversal between two tool paths, it will stop jetting to save the abrasive. So the garnet abrasive does get consumed at a different rate based on how fast you're doing the cutting. But just to save the material, it will it'll stop during a traversal. And I believe at this point we're doing a perimeter, which will be the final cut.
Yeah, the video stopped working for me. Oh, it's kind of back on, but very choppy.
Yeah, that's okay. If everyone got the gist of it there, that's what we're aiming for. And you know what? As we all know at this point, it's never going to work 100% in our current climate.
So I'm going to be sending a recording of this tomorrow, so I could include those videos in that email too.
Yeah.
That'd be
Thank you,
great.
Kristen. What I'll do now is see if this typically works okay. I'm going to share from my phone here. All right. Jim, how's that looking for you?
Crystal clear.
Oh, beautiful. All right. Okay, so what I cut today are these two parts here. And that first video I played that some of you may have not seen, that did an etching, as you can see on here. And the first video, the etching really kind of just made the water splatter everywhere because it wasn't jetting through the material. But you can see the etching is quite nice. However, on the corners here, you see when it rounds a corner, it does a little bit of a deeper mark. So it's somewhat challenging you're really kind of working on specialized artwork in order to produce an etching with a waterjet cutter that looks very smooth, but it's certainly possible. This was a really fun little piece to do. And this is just a little hex wrench that I made because there are some nuts in the machine that are used to take the whole bed out. So yeah, so this is a nice piece of steel, came out great. And this is the one that had no etching on it, that just cut straight through the material. All right, and here is the final part of the design I did in Fusion. And it actually pivots very, very smoothly. And I wanted to talk, before I kind of take some questions and we start talking a little bit about our own projects, the last thing I want to talk about here is my 3D printed parts and how I integrated these. So let's see if I can swap back over here.
You could also double as a hand model. I just thought I'd throw that out there.
Well, thanks, Jim. That's very nice. I mean, I did my nails especially for today. So. Oh, that's good. Okay, let's see if we can get this. Yeah, I bet full screening plays a role here. So can you folks see my Fusion again?
Yep.
Yep. Okay, great. Okay. So when I went, through this process, this is, something that if you're working with SolidWorks or Fusion, Onshape, and I'd love to hear this from some of you, if you're, if some of you high school teachers, how are you integrating joints in your assemblies when you work with the students? That's something that I, always kind of hit on when I work with assemblies here. In this case, I have my joints up here, and oops. Yep, so now I can actually just kind of do a little simulation of how my part is expected to move. So one of the things I want to highlight here, moving away from the waterjet cutter for a moment and onto a 3D printer. First of all, this base piece here was kind of made out of necessity. You can see I put in these little pins to anchor the lower part of the arm on, and really that's not a good solution. I did that just because I didn't have hardware. Really what I should have done is had just a hole in where the pins are and then put hardware through. And I did think about this, and I'll try to follow up with Kristen on this, but if you folks are for those of you using Fusion, if you would like this F3D file to show your students, one thing I think about when I do these quick sample files is showing students and saying what's wrong with it. Seeing if they can identify where there might be some hang-ups in the design, how they might improve it. So I'd be happy to share that with you folks. And the other thing I want to move on to here is a nut and bolt. So this fixture right here is actually a two-piece nut and bolt. And I was really thrilled about doing this because I printed this on a MakerBot Sketch, which is really kind of an entry-level printer and not as forgiving as far as mechanical tolerance goes. But after learning a little bit more about how I can change the threading, let me bring this up here, how I can change the threading tolerance of where the bolt fits into the nut, I really made it very forgiving and just added some extra space in there and even kind of curved out the edge of the thread here. So it was a little bit more versatile for a 3D printer. And I had a lot of fun doing this. Is it super practical to use a plastic nut and bolt? That's something I'd love to hear from you folks on. I think as far as a designer standpoint goes and for prototyping, I think it's awesome personally. But in the long run, if you're developing parts for robotics projects, would you want to use, where could you use something like this? Where could you actually have a 3D printed nut and bolt? So let me pop back out of sharing. Yeah, and here's the result right here. And when I fit this together, I was like really surprised at how well this screwed together. So, you know, if you're like when I thought about this again, this is really a large kind of cylindrical nut and bolt fixture here. And I guess a good example would be like, you know, let's say you're looking at McMaster-Carr or some, you know, catalog for hardware or at Home Depot, and you really can't find that right piece. Like it's not, you would either have to machine it yourself or get it custom made or design it and 3D print it. And that's where it could come in handy here. And also, the other thing I want to share about this is the way I should say the orientation that it was 3D printed. You can see, let me unscrew it here. It was printed with no support structures, which would be, you know, which you could get away with if you don't have your, you know, these edges overhanging too much, but also if you have a 3D printer that has a dissolvable support, you could really print it in any orientation. But because I printed it in this orientation, the this serving as a bearing, if you will, against the inner edge of the arms here, it really works well because it has, you know, it's parallel to the direction it's rotating, and it's just very, very smooth. Like, you know, came out great. So how much different would it be if it was like printed the you know, kind of perpendicular? It might be a little bit less forgiving. So that was pretty neat. I think I'll stop here. I want to bring my slides up just for kind of a finishing point here, and then I'd love to hear from you folks.
Adam, I think a better application, a better printer, a better material for that would be to use something like the Sketch. I mean, not the Sketch used would be for the MakerBot method, or even like the F170 using like Duran, or the new carbon fiber that's used on the F170, and also the method too. So I mean, I think you could probably get some decent results out of that as well.
Yeah. Yeah, and you have a lot more availability when you're working with the printers that have the dissolvable supports, right? You just you don't have as much limitations. And for, for educators who might have those time constraints, have the printers that are more robust and kind of like plug and play, you can really focus more on your design as opposed, because the output's always going to be the same, right? With like the higher quality printers. All right, so the last thing I kind of want to finish on with this presentation is kind of the entryway into our discussion point. And what you see on this slide are images that Dave Kempsky shared with me from a first robotics project that his son was involved with. And I really love these images because this is such a great application for using the Waterjet Cutter for a robotics project. And Dave, if you want to speak a little bit to this, I would love that. And just maybe tell us a little bit about what the goal was and how it met your needs.
So this was last year before COVID struck. So for anyone that was involved in FRC, I'm trying to remember the exact project or what the goal was. Probably picking up balls of some sort. And so the front of that, the first picture on the left, I think what you can see a little bit of an intake manifold, or an intake, not an intake manifold, it's an intake for the ball intake. And so there was the second picture over with that, for that ProtoMAX Waterjet cutting right there, that was used, one on those on each side. And the next picture shows the next picture actually shows it within the, so there's one of those on each side. And the students designed all that, and I just cut it. I cut what they wanted me to do, and it worked really well. They never got a chance to put it into action, into competition last year, so it's a shame. But it was, for someone without a lot of experience in running the machine, it was really easy to use. And Adam, I don't know if you can just show a quick, just move or get your phone just to show the footprint of this machine. The machine itself is, doesn't take up that much room. Jim, you probably, you've got yours in place there, and you can probably, I was surprised at when we first got ours. So for what it's capable of doing and the little space that it takes up, you're not getting it's not like a, they have some of these Waterjet cutters that are, 4x4s, 4x8s. This is certainly not like that. But for a lot of projects, for a 12 inch by 12 inch, it and you could do things a couple inches thick. It'll serve the purpose for robotics projects, that's for sure.
These are some more decorative pieces here, and these two here I did for really just calibration parts. This one came with the software just to see how true a 1 inch measurement was on the X and Y axis, and then the diagonal. And then this one here was me testing the quality levels. So 1 being the roughest and 5 being the finest. And it's pretty tough to see, probably, but 5 is definitely a lot smoother. This was also me learning about how, the Waterjet, if you just start trying to etch with the Waterjet with a free-floating number or text like this, there is no lead-in. It has to have a lead-in, which is an interesting part of of the tool. So the lead-in happens on the number, and you can see that it just actually blows through the whole metal. So that's why I went off and produced this part, to learn how to kind of navigate how you would do a little bit smoother of an etch by leading in from the outside over here. And it certainly looks much nicer. While I have the cam up, any questions? Anyone want to jump in, like water jet related questions.
And maybe we could just show utility hookups on that.
Sure, yeah. Yep. So we have one, just one line going, right? One water line going into the machine here. And that serves both the jetting and this kind of peripheral of like a hose to fill the machine and rinse it after you're done, which is pretty nice. And I think we're at a 220 power supply, Dave, is that right?
208, I think.
Okay.
Yep. And yeah, one of the things about the machine too, if just in terms of space planning, you need to have a little bit of, look in the back of the machine, if you can point to that, to the line that's right there. Yep. That line will go in and out. So it's being high pressure. This is the line, the water line that supplies, that comes right from the pump that supplies up to the head. And so that will actually traverse in and out based on where it is. So it's got some flex to it. But you will need probably about, I'd say, 18 to 20 inches of space in the rear of that machine. So that gives it the space.
Yeah. And this is our garnet abrasive hopper right here. It's pretty neat to work with this. One part of the technology that I'm kind of blown away by is that as the machine is jetting, it produces a vacuum that puts pressure, or like brings pressure on this tube here and sucks the abrasive straight through the tube and just mixes the water jet with the abrasive at a very smooth, equal level. It's pretty neat. And you can see there really aren't too many materials that will resist this. Even the slats in here that are used for the bed take a beating, but they last quite a while, I would say. These, I actually just flipped these recently. So yeah, I'd love to hear from anybody if anyone has any questions, or if you're eager to share what you've been working on. That's something that I've really been wanting to make these meetings about, is like have a good chunk of it about teachers sharing what projects you're up to. It doesn't have to be necessarily on waterjet or 3D printing. It could be anything.
I mean, I can share, I was working on a project for the Boys and Girls Club where we were building, using a 3D printer, a MakerBot and a Dremel to make prosthetic hands. So, but no, like the designs were already made. So this was just a project where, you know, you were supposed to size it to a recipient and then scale up or down the parts to match the size for the person's wrist. So these are people who were born, you know, without a hand. And I forget the name of it, but it's kind of a nationwide project. It just tries to match up anyone who has a 3D printer with a potential patient or person who needs a prosthetic hand.
Cool. Thanks, Rich.
I've heard of that. I thought that was even an international program.
Yeah, actually, I think
that's great.
Would anyone else like to share?
So I had a real quick question. Is the water jet going to take over for the laser?
That's a great question. All right, so first of all, most folks that start laser cutting, like with, I guess at the high school level, if you're bringing a laser cutter into your makerspace, it's a CO2 based laser tube, and you aren't cutting metal at all with that tube. You will be marking metal, or just like marking like an anodized metal of some sort. To my understanding, and I haven't even had many opportunities to work with these lasers, but the fiber, and Dave, you might be able to speak to this a little more, but the fiber lasers, which the technology is still something I'm understanding, are much more powerful and capable of cutting through metals. And the water jet, and again, it's a laser, so I imagine that there are material restrictions and limitations from one to the other, with a water jet just being if there is much heat being generated, it's got to be so minimal being inside in this huge water tank. So I think the versatility of a water jet is much, much higher.
Yeah, I think there are projects that would call for both, of course, and there are powerful lasers out there. I mean, these YAG lasers that can cut through some fairly thick materials. But there's heat being generated, so there's going to be warpage, and there are certain materials that you cannot cut with laser. So certain types of exotic thermoplastics comes with carbon fiber. I don't think you want to be cutting things on laser with carbon fiber, but you can absolutely do it with a water jet cutter. Yeah, there are materials definitely out. I mean, I've got a post on our website about cutting through granite. I cut through a 2-inch piece of granite with this thing. So you can absolutely mark granite with a laser too, but you're going to be limited on what you can do. So the only way you're going to cut through the types of metals that Adam showed is going to be with a much more powerful and expensive laser. So you're talking something that's around $30,000 with this water jet cutter. Of course, we're limited size, and it's got water in it, so there are certain things you don't want to put in water. But where it works, I mean, these are just all tools. Laser is another tool. This is a tool, and so it's a matter of finding the right projects and materials that match up to your needs. And having a tool like this is absolutely going to come in handy, I think, for a lot of you guys. So, but it just it's all application driven.
And that was a 12 by 12 usable space?
Yes.
Yep. What's the next one bigger than that?
They go up, so the next one bigger than that is they have a 4 by 4. And it also goes up to almost $100,000.
Yeah.
So it's like they jump in price big time. And the ProtoMAX was the thing we love about the ProtoMAX is it's a great fit for our customer base and for maker spaces. It just fits in really, really well. Again, you start getting into those higher price range, and you're going to ask yourself the question: do I really need it? And how often am I going to need it for those types of projects? So, I will say the school, when my son goes to school, we partnered with a company, a local company in Gloucester, Mass, that has an OMAX, big OMAX water jet cutter, and they've traditionally cut. The past have cut the entire body out, and so they still do that because it's much larger. But when the parts for last year, the parts that were needed for this, they said these are all the peripherals, and that's what we were able to do here on this machine. So we were limited on the size, of course. Those are done with a different technology. Of course, with FIRST, you can actually get the prefab body already if you want. There are other ways of doing things. Think of like with decks. So, This is this is what I also think about with Vex robots. I mean, for doing custom, I mean, Vex got a lot of parts to choose from, but man, you could really customize your Vex projects as well. So, anyways,
Dave, I also want to add on to that, and I don't know if the ProtoMAX has this peripheral, but there are OMAX machines. OMAX is the company that makes the ProtoMAX that have tilting tool heads. So it's, I don't even know what you would call it, a 2.5D sort of tool path. So if you imagine like a computer fan, right? The contours of a computer fan, you could actually machine out using the waterjet cutter with that technique, which is pretty neat. And of course, that would be a fan that would be made of metal or highly strong.
For doing blades, yeah, doing turbine blades, I think.
Yeah, there you go. Yeah,
it's almost like a fifth axis, like a makes it 5-axis. So I never realized waterjet cutters could do that. That goes beyond, I think, most of what we would be capable of offering, because that's where the technology gets very, very expensive.
Yeah.
But do you see that happening in the future, though? Next, let's say 5 years.
I mean, all the prices of all those things and eventually trickle down. It's taken a long time for waterjet cutters to get to this price, though.
And Stephen, are you asking for like AET specifically?
Well, I'm because we're getting that new school, and I bought a laser last year, and then COVID hit, and I never set it up. Now I'm seeing the waterjet, and I can see all the properties that are all the things that we can do with that. But I'm holding on for a 5-axis machine. Something that can maybe it's a mill instead of a waterjet. But something, there's got to be that next piece of technology that I want to be the first in Rhode Island to have, and I'll ask for it too. I don't know if I'll get it, but I'll ask for it.
Gotta start somewhere.
Yeah.
That's great. Well, we should all chat it at some point, Stephen, on that, because right, there are pros and cons to every setup, whether it's a mill, laser cutter, waterjet. Again, Dave always brings it up. It's all about applications, which is 100% true. And my favorite thing is, how do you mix the machines together? Like, this is why when I set things up today, I was like, I have to do waterjet and 3D printing. I don't want to just show you guys a waterjet project. I want to show you integrating these things together. Josh, I see you nodding a lot there, and I don't think you've introduced yourself, but you're on video, so I'd love to invite you in and just.
Sure thing. Yeah, I'm sort of an outsider. I worked in education for a number of years. I worked at Wentworth Institute of Technology, but now I've switched gears a little bit. I actually work for the Autodesk Technology Center in South Boston, and we have a 14 by 10 waterjet, an OMAX there, and it's also 5-axis. And the waterjet, that thing, we do so much stuff on it. We've cut, wood, metal, acrylic, stone, like you said. I have a stone in my backyard that's been cut on the waterjet. It was just somebody needed a cylinder cut. They wanted a round piece of rock. What they didn't want was the rock with the hole in it. So I took the rock with the hole in it, and brought that home and put it in my garden, because it's cool to have a rock with a hole in it, It was going to get thrown away, I think, otherwise. So, but that, like you said, the application of like taking the parts from the waterjet and putting them onto like a mill or like laser cutting them, that stuff is super cool, where you incorporate two pieces of equipment. The things that you would think, oh, I should just put this on like a 3-axis mill. If you start to really think about it, you can remove a ton of material and a ton of time by water jetting it first and then putting it onto the mill afterwards. If you see cool videos of people making soft jaws and stuff like that, you basically make a soft jaw you can even 3D print it, and then put that water jet part into that soft jaw, And now you don't have nearly as much roughing that you would have to do. It's just a matter of finishing those small areas. Maybe you're trying to put a bearing into an area that has a very high precision tolerance that the water jet doesn't really create the right surface for that, but the mill does. So using those two things in cooperation basically is just such a cool process. And the water jet just lends itself so well to just sort of aiding in that process, you know.
Yeah.
And I totally agree with what you said with the laser cutter as well. You know, like the laser cutter is another great tool that just works really well in unison with other stuff.